In physics, we use diagrams to visualize concepts and mathematical relations and illustrate the interaction of variables responsible for a certain action or phenomenon. One of the most indispensable of these is what we refer to as free body diagrams, which will prove to be crucial in representing forces and their interactions as we study the different laws of motion. Mastering to construct a free body diagram requires diligence and attention to detail, as well as the openness to correct the misconceptions that we have about force and motion. This lecture is the first step towards this process. A free body diagram is a vector diagram that illustrates the overall picture of the magnitude and direction of the forces that influence an object in a given scenario. This figure in your screen shows an example of free body diagram with four types of forces influencing the object. We have normal force, represented by an arrow upward, the weight, which is represented by the arrow downward. Then, we have the friction force and applied force, opposite with one another and parallel to the object. The arrow's size signifies the force's magnitude, while the arrow's direction signifies which way the force is acting. In the previous lesson, you have learned the different types of forces that influence the motion of an object, right? Let us see if you can still remember them. I have here a series of questions and answer based on what you remembered. Your knowledge in these types of force will come in handy as you attempt to represent them in vector diagrams for the problems related to motion. Going back in the free body diagram, let us illustrate a free body diagram from a real life scenario. Say, we have a runner on her starting block. Of course, illustrating this, we start with her weight, which keeps her on the surface of the earth. Next, there is a vertical component that counteracts her weight and a large horizontal component that accelerates her as she runs. We say then that this resultant force is the force of black on a runner. In constructing free body diagram, here are the steps we need to follow. First, read and ensure you have understood the problem at hand. We can create a mental sketch of what is happening in the scenario. Second, take one object at a time and draw a free body diagram for it that illustrates all the external forces, including the unknown ones, that act upon that object. The net force, or the sum of all forces, cannot be included in the diagram. Remember, however, that if more than one object is presented, individually draw the respective free body diagrams. Next, we will draw the arrow that corresponds to each vector according to its magnitude and direction. Again, the length of the arrow represents the magnitude of the force, and label each accordingly. Then, present the x and y components of a particular force. Lastly, solve the equation for a known value. Let us apply this in sample problems. Draw a free body diagram for a paperweight that is rests on a desk. The first step is to list the forces that acting under consideration, along with their respective magnitudes. Here, we have normal force and gravitational force or weight. Since the paperweight is at rest, how do we draw the length of the arrow? Correct, it must be equal. Next, we identify which of the forces are along the x and y axis. We can make a table to easily represent it. There are no forces in x-axis, while the normal force and weight are found in the y-axis. Lastly, from this information, we can draw the free diagram as this. Notice that the object is at the center with the length of the arrows equal in length. Then label it. What must be the label in this part of the arrow? Correct. It must be the normal force pointing upward, while opposite to it is the weight. Let us have a more difficult example. Two trunks A and B with masses 15 kilograms and 13.5 kilograms respectively are attached to a lightweight cord and at rest on a frictionless horizontal surface, as shown below. A 35 Newton horizontal force is applied to the 13.5 kilograms trunk. Find the tension force between two trunks. Again, since there are two objects involved, it is necessary to draw the two free body diagrams individually. To do this, we can list the forces acting on each object under consideration along with their respective magnitude. For both of the trunks, they have weight, of course, the downward pull. Opposite to weight is the normal force, which the two also have. Both of the trunks are connected by a cord. Therefore, both have tension force. But only for the trunk A that there is applied force. And those are the forces present in this situation. Next, we will identify the forces acting along the x and y axis. Let us make a table. For trunk A and trunk B, the normal force and weight are found in y-axis, while the tension force is found in the x-axis. There is a horizontal applied force as well given in the problem for trunk A, and therefore it is found in the x-axis. Now that we know all the forces in this situation and in which axis they are found, we can draw their free body diagrams. For trunk A, we will draw it as this, while for trunk B, we will draw it as this. Notice that the illustrations clearly represent the direction and magnitude of the force involved in this problem. And that's it. You will use this skill of drawing free body diagrams in the next lessons, especially when we represent laws of motion, which we will cover in the next module. That is all for this lecture. I am Gilmar De Castro.